Hello everyone, uh, welcome to the next module of Linux administration course. Before starting the session, would you please confirm if you can hear me well and see my screen? Alright, so I have confirmation from one of the participants, so I'm assuming that others also can hear me well. So today we will start with some of the compression techniques. That means how to compress and archive your files. Okay. And then we'll move on to the next topic regarding the rotation of the files, log rotation topic that we have concluded yesterday. Okay, so in Linux there are different ways of compressing your files. So one of the type that is more often seen is your TAR, TAR, tape archive. Okay. Using tar command, you can both compress as well as create an archive of the files. So tar, as you can see on the screen, so this command, among this, C is to create, V is to display the verbose, okay, F is to create a file. So here, these three arguments, they primarily create an archive of a specific directory. Okay, so creating an archive and then extracting an archive. We'll take an example and check this now. So let us take temp directory. I'm going to name it as tmp.tar. So if you remember, there is no such convention that we have to give .tar as an extension. Even if you don't give it, it is okay, but it is considered as the recommended approach so that it will be easy for others to understand or identify what type of file it is. Okay. So it says, so this is a POSIX tar archive file. Okay. So this is how we create this archive. Similarly, C is to create, okay, and X is to extract. This is the file. Enter. You will have a temp folder created here. These are the contents. Clear? So this is the basic creation and extraction of archive file using tar command. So we can use the combination of tar and compression techniques like gunzip and binary zip, okay, and create a compressed archive file at a time. Let us take the same example. Okay, so here so it is the same temp folder. Now apart from tar, creating archive, I'm also trying to compress it using gunzip. So CVZF, Z is to create a gunzip. We can also create only compression using the command gunzip. Okay, that means it is possible to split these commands. So just only extract it. Anyhow, after extracting the file, you have to again extract from the archive also. So together we can perform it like this: tar hyphen cvzf. Similarly, the extraction process is tar hyphen xvzf. Okay, temp.tar.gz. So you'll have temp folder again. So this is a gunzip format. Similarly, we have another format called as a binary zip. So instead of gz, we say bz2. Another thing, when you're working on a command prompt, okay, so whatever argument that you have given previously, so this is the argument that I have to give as the argument again. So rather than typing this every time, I can simply do press these two, alt dot. Okay, just make a note. It will really speed up the things. So here you can see. So this is called as a binary zip. So again, if I want to use the same argument and try something. Okay, for example, now I have to what? Extract this file. So tar xvjf. I need the same argument, right? Alt dot extracted. Again, I need the previous argument. See how many times. So you would keep taking the previous argument, and say if you have a bigger path or a big file name, it will be much quicker rather than using tab also. It is much quicker if you do alt dot. Okay. Now, so tar, along with the tar, we use gunzip, we use binary zip. Okay. So if you have a tar dot zz file, okay, I hope this concept is clear. Now here, hyphen cv save. Take the same example. For example, this is like this. So we created dot bz. Okay. Now, if I do this, hyphen cv. So in order to extract hyphen xvjf, right? So if I don't put j, I'm sorry, xv. Okay. So xvjf is to completely extract it, right? So if I don't put j, then I'm only going to uh, extract the archive. So the compression would remain the same. So now the file name would change to temp dot one second. Okay, I'll start from the beginning. So if I do tar xvf, Now see what is left. So this is just a compressed binary zip. One second. Okay, so this is what I meant to explain. So we have tar combination of binary zip. So this is the command 1zip2 to simply remove the compression extracted. So your archive file would remain the same. Now do -xvf, so that will give you temp folder. Okay, the same thing is applicable for gunzip also. So rather than this command, you have to do gunzip. Gunzip will extract it for you. Other than this, you might also find zipped files, zip. You can use unzip command to extract them. Similarly, vice versa to create it. So mostly these are the different types of files. These are the different types of compressions that you would see in Linux. Okay, at least having an understanding of how to extract out, how to create these files is sufficient. Alright, so the next topic is on log rotation. So yesterday, if you remember, we have gone through the different types of log files, right? So there is a service in the system which is called as rsyslog. Rsyslog is responsible to rotate all these log files in a Linux system. Okay. Now, service rsyslog status. So rsyslog D or rsyslog is a service that is running in the system. So what rsyslog does is it is going to rotate the log files which are present under varlog directory. So how does it rotate the logs? So what is the criteria? Where does it get the information on what files to rotate, what size they reach? So when does this rotation happens? So obviously there will be a lot of such questions that would rise, right? So as you can see, this is what we have seen yesterday, some of the log files and their corresponding importance. So boot.log, if you have MySQL database, you will have that. Authentication log, yum.log, and mail server logs. Cron is something that we'll see today. Cron jobs, which is a cron scheduler, kernel logs. That's pretty much about. So this is a message log, which is a generic log. Okay, other than this, as I said, if we install web service or an Apache, you will have a HTTP directory. So depending upon the service, there could be a separate directory created under the varlog folder, or if it is a third party, not the system related service, if it is a vendor based package or a service, then it might create logs in a separate folder. Okay, now so logrotate.conf. So this is the corresponding configuration file from which rsyslog service will get the information. Again, this is called a global configuration file. So global configuration file means it contains generic details that are applicable by default. Okay, so if you want to have configuration specific to a service, for example, I would say that the same config details which are there in this file, they are applicable to all the services in the system. Okay, and now I say that I have come up with a new service called yum, and for this service I want to have something specific configuration. I don't want these generic details because that doesn't suit my requirement. Okay, so in those cases we have, so along with logrotate.conf, here if you press tab, okay, so we have something called logrotate.d. So here you can see there are some specific config files. So for yum, so this is the path of the log file that the service has to rotate, and there are some parameters over there. Okay, so this is specific to yum. Okay, or so now I have mentioned two different types, right? One is global, another one is specific to services. You can also have something like part of the details are in global definition, part of them are part of the service definition. That means, so these are only the parameters which you want them to be unique for that service. So include them in this config file. Rest of the parameters which are common, you uh, leave it as it is inside the global configuration file. So you can also try doing that. Okay, so I hope it is clear now, right? Global and service specific. Okay, so this is what the configuration is all about. Okay, so the service has to pick the configuration. All right, so how does the service pick these configurations? So that is the next question. So we have something called etc. So there are some folders you can see: cron.daily, cron.hourly, monthly, weekly. You remember what I have explained about cron yesterday? Cron is a scheduler. So you tell cron which job to run, what time to run, how often it has to run. So it will take care of executing your instructions. Alright. So it will reduce the manual work, to attend or implement some steps every day at a specific period of time. So I can say that mostly in order to perform those repeated tasks, okay, which can be automated using a shell script. So those things can be given to cron. It will take care of executing those scripts at a given period of time every day. So system has, so by default cron service will be up and running in your system post the installation, because the operating system itself makes use of the cron service. Okay, so here in these folders would contain some, they can contain daily jobs, hourly jobs, monthly jobs, or weekly jobs that the operating system makes use of for its functioning purpose. Okay, now log rotate service, in fact it is one of the system service, which takes care of rotating the logs that automatically get created in the system. Okay, so among these different folders, if we take one folder which is cron.daily, so that folder has a file called logrotate. So this file is a script. So here you see there is a change in the display color of these files. So in my system, mostly if I give execute permission to a file, then it changes the color stating that these are all shell scripts. Okay, executables to be more specific. So logrotate is one. So logrotate is a small shell script. So we have shell scripting topic later in the course, but I'm going to quickly explain what the shell script will do. So that would help you to have an overview of the shell scripting topic. Okay. And the first line of every shell script starts with a shebang line, okay, which is in this format. So hash exclamatory mark bin sh. It can be bin bash, it can be bin ksh. Okay, if you have heard about Perl scripts. Okay, where is bash? Bin bash. Where is sh? Bin sh. Where is Perl? User bin Perl. So you check like this on where uh, the shell is. So basically, what are these? Bash is your shell interpreter, right? So when you write a script, in the beginning of the script, you mention the interpreter that is going to execute your script. So this script is a shell script, so it will run by making use of this particular interpreter. In a shell script, it is the only first line, that is the shebang line, that starts with a hash. So rest of the lines, anywhere you begin with a hash, it becomes a comment. Okay, only hash exclamatory mark at the beginning of the line represents your shell interpreter. Shell, rest of the file in a shell script, if you start a line, or if any line if you want to comment out, you put a hash in the beginning. That is not executed. 2 steps over. Third step, a shell script, to say simply, is a set of commands that are executed serially one after the another. Okay, that means I open a file, and in this file, one line I will say ls, second line I will say who I am, third line host name. These are all simple commands that we have seen so far, right? So if I put these commands one after the another, and I give execute permission to this file, and if I run this script, all these 3 commands will be executed on the corresponding shell prompt, and it will display the output on the screen. To say this is what shell script is in a simple terms. Okay, so we have other concepts like loops. Okay, if loop, for loop. So all these loops. So what is the necessity of the loops in general? They would help you, uh, to create some logic. If you have some logic that to implement, so these loops would help you. They act as a glue among all these commands. So these commands along with those loops would help you in order to interpret some logic or some condition based on which your script has to work. So other than commands, mainly commands, and then we have loops, and then we have concept of variables, system variables or shell variables or special variables. So we have 3 different kinds of variables in the system. So that is the third thing that you will be using. So remember, shell script basically has system commands, and then all these loops. So system commands also include the normal commands that we are using. It also includes the utilities like awk, scd, grep. They are also considered as system commands. Okay, so everything, all these things would come under one category. Second one, all the loops, if loop, for loop, while loop, until, all these loops is the second category. And the third category is your system variable or special variable or environment variables which are there. Together, these three things, they create your shell script. That's all. Okay. Now here, if you see, I'm going to show you all those three things. Okay. So the first line, what does it say? It says user has been log routed. So, don't go to the second half of that line. Stick to the first half. So user has been log routed. So that itself says that it is a binary, right? Which is because it is present under has-been folder. So user has been log routed is a binary that will get executed. It's like a command. And following that, we have passed a configuration file. That means this command will get executed by taking some arguments in the system. So those arguments are being passed in the form of a configuration file. Okay. Clear? So that is line 1. So we have a binary command covered over there. Second line, exit value is equal to $? So we have seen some variables in the system, right? So echo $home. So this is an environment variable. Echo $shell shell variable. So these are like environment variables. Other than this, we have some special variables. Okay, like when I execute a command ls, so the command has successfully executed, right? So the exit status of a command execution can be success or failure. Agree? So when you execute a command, it can be successful or it can be a failure. So this status, okay, is represented as 0 or 1. Success means 0, failure means non-zero. Success is 0, failure means non-zero. So this exit status of every command that is executed on a Linux prompt is stored inside a variable called $? Now I ran the command called ls, echo $? enter. So it is 0. Clear? Ls, if I do something like xyz, there is no such file or directory, non-zero. Okay, depending upon the failure, okay, it would either say 2 or it could even say a number which is more than 2 or 1. Okay, any non-zero number represents a failure, 0 represents a success. Like that, we have other special variables. We'll come back to that topic later. Okay, so what is the second step now? Exit value is equal to $? I say x equal to 2, echo $x. So the value of x is 2. So we have stored that value inside 2, right? Similarly, you remember about these codes that I have said yesterday. Any command that you execute inside those codes, okay? Any command that you keep inside those codes will get executed. So x equal to, inside the codes I executed something. Now what is the value of x? The output of ls-l command is stored inside x. So okay, remember this. There is no specific topic to. I mean, there is no categorization for these kind of commands. Whenever it comes based on a need basis, I'll just give you these commands. Okay, so you can store, you can execute and store the output of commands like this. So you have stored it. Similarly, when I ran a command called ls, So there is this value stored inside dollar question mark. So if I do x equal to dollar question mark, so the value of dollar question mark is stored inside x. Simple. Now check the second step. It is clear. Now come to the third step. If you have very basic experience of loops, the third step is self-explanatory. So what does it say? You understood the previous step. Now in this step, if dollar exit value not equal to 0, then again this is a binary which is taking some arguments, and there is a message stating that alert exited abnormally with this particular exit value. End of the loop, end of the script. So the log rotate command is executing. Whether this is success or not, we are checking here. If it is not successful, we are running a command and we are throwing an error which is stored somewhere. If it is successful, then it is fine. So this is the log rotate script. So it is not just about running the scripts, but we should also be in a position to store the error messages. So if a script has failed, so the admin user must be informed on why it has failed. Okay, so to ensure that it is not permanently failed, so he has to cross check. He has to check whether it is a common error or whether there is something other that has created in the failure of the script. So along with the generation of the script, we need to create the log messages. And how to create the log messages, we have covered yesterday. We have seen how to create general log messages, error messages, right? Redirecting standard output, redirecting standard error message, all those things that we have seen yesterday. You remember that, right? Perfect. So as a part of log rotate service, the system is going to run this binary by taking arguments from logrotate.conf. Now what we'll do, we'll go back to logrotate.conf and see the contents of logrotate.conf. So what arguments are being passed from this file to a command called logrotate. So some of these arguments include rotate log files weekly, and then it says keep 4 weeks worth of backlogs, create new log files after rotating the old ones. Remember, rotating means the existing log file which is there. For example, it is called yum.log. After it reaches a specific limit, or maybe after a week of time, that is what is configured here. After 1 week, what the service will do is move that yum.log by attaching a date stamp to it. So yum.log hyphen xyz date, and it will move it, and then it will create a fresh yum.log file inside which new logs will be updated. So that is what this is. Similarly, date extension. So this is what the date extension I was referring to in the previous step. While rotating, add a timestamp. Similarly, if you want, include a compress timestamp here. This is commented here. See. So going forward, it is not just about shell script, but most of the time, shell, Perl, even Python scripts, okay, or Linux configuration. Let us stick to Linux only. So Linux configuration files, Linux shell scripts. In both of this, a comment so hash represents a commented line. Okay, so this will not be considered. Just remember that. So other than these arguments, it also says include etc logrotate.d. This means include the contents of logrotate.d. Now what is there in logrotate.d? It has service specific scripts present inside logrotate.d. So those scripts will be considered here. Some more configurations that are mentioned. So here, like, this is specific to BTMP. So log file name is mentioned, and then missing OK. So monthly, and then create the file with this timestamp and this owner. So owner should be root and this, and then similarly rotate after every 1 week. So like this, these are the definitions. 1 second. I hope the concept is clear, right? There are few steps that we can also follow in order to the log rotate service basically runs as per the schedule. So when you create a job, you copy it to logrotate.d. So based on the interval or whether it is weekly or daily, that job will be picked and it will be executed automatically. Okay. But if you want to test the log rotate service, what we can do is we can create a sample configuration. For example, as you can see on my screen, so logcircle.log is a sample configuration file that you create inside the logrotate.d. So take any of the files just to copy the context. So copy it and name it as logcircle.log, for example. Okay, and corresponding to logcircle.log, there must be the actual log file that should be present in the var log, right? So for example, create that log file. It can be any xyz.log. Okay, and these are the corresponding parameters. I also mentioned size 30k. That means once the size of the file reaches 30k, then it must be rotated. Okay, and yeah, so this is how you can forcefully make the log rotate service to execute logrotate space -f space etc logrotate.com. So it would get forcefully uh, executed. So it will run that service. Running that service means what it will do. So it will go to that particular log file. It will check the timestamp. It will check whether it is time to rotate it or not. So in order to ensure that it rotates the file, what we do is we increase the size of the file. Just throw some dump into the file, make it bigger than 30k. So the moment it reaches 30k, log rotate will run the log rotate service again. Then it will just move that by attaching a timestamp. Okay, so that's what log rotate will do. I'll just give me a second. Well, is this step clear to you, or do you want me to explain this again? Log rotate service. Okay, so finally one participant has responded. Correct. So the question is, when we want to test it, where should we keep uh, the configuration file that we have created? So you have to keep it inside logrotate.d, and then corresponding to your configuration file, you have to create a log file inside var_temp, inside var_log, and increase the size of the log file, for example, to 40K, and specify a limitation that if the size of the log file is 30K, then rotate it. Okay, so then you run the log rotate service forcefully. Just give me 1 minute, please. Hello everyone. So I have sent the presentations. Did you get a chance to go through the presentations? Also the installation document that I've sent. So how many of you have successfully installed the CentOS operating system? How many of you have CentOS available with you now? How many of you have started practicing? Okay, Bharat has responded. Only one. Mike, 2. Okay, 3. Okay, perfect. I'm sorry, Bharat, I didn't get your message.
Hello. Hi, Sharon. We didn't receive any slides yet. So if you get the slides, that would be help us to understand better the class slides.
All right, everyone. I hope you can hear me well? Sorry. So let's move to the next topic about the cron scheduler. There is a small network issue. I could see that the connection has been lost, but it is back. Could you please quickly confirm if you can hear me well? All right, thank you. So let's get started. So the next topic is about the cron scheduler. Okay, so now we'll see, as I've explained, we'll see how to make use of the cron service, how to schedule jobs using the cron service. Okay, in fact, log rotate is also one of the service that cron handles. Okay, so as I've said, functionality wise, give a job to cron, like giving a script to cron. We have seen the script log rotate now, right? So it is made part of a folder called cron.daily. So it comes and picks it daily. But now what we'll see is we'll try to configure a job at a specific point of time, okay, with recurring dates, and then we'll go through the cron config file and the cron log file, and we'll see how cron executes those scripts. Okay, so as I said, by default cron service is available in the system. Service cron status. Okay, another important thing in the presentations that you would get, okay, the presentations that I'm sending you, it has instead of service cron status, it says systemctl start cron. Okay, the complete notation used based on the CentOS 7. So this you are already getting familiar with. So if you have CentOS 7, the slides will be helpful for you. Just a small change in the syntax between the two. Okay. So service cron status, and you know how to enable it at the boot time, right? How to make it permanent in the system. So that is already done in fact for cron service. So okay, the next point is, so as per the functionality cron, we can automate the things using cron. So who all have the authority to make use of cron service? Every user in the system, in a Linux system, every user can configure cron jobs. Okay, so I should say that cron configuration file is user specific. Okay, so there is one global configuration file which the root user has access to. All the rest of the users will create their own cron configuration files. Okay, so first of all we'll see the global configuration file, which is cron tab, etc cron tab. Just type cron, press the tab twice, you will see the file along with daily, weekly, hourly jobs. There is something called cron tab. So the cron tab file, it will give you details on how cron works. So there you can see shell to bin bash. So cron is going to make use of this shell in order to execute the scripts. Okay, and then path is equal to sbin, bin, user bin, user bin. I think I have not explained you on how to export system variables in the system. Okay, I will explain that to you. That means to say simply, when you install Java and Windows system, you update the path variable, right? So that every time you connect to your system and run Java, Java binary gets executed. The similar concept is there in Windows also, I mean in Linux also. So I'll explain that in some time. So path variable, basically the importance of path variable is, so whenever cron is executing in the system, it will go to sbin folder. So you gave some command directly, ls command. So ls will be executed in the system only when it is part of the path variable. Okay, so otherwise you have to say /bin/ls. That is a generic concept. So I'm executing a command called ls. It is successfully executing because ls command is present as a part of the path variable that is configured for the root user. The root user has bin folder. So bin folder contains ls command. Where is ls? Bin ls. So this is what path variable is. Every user will have a set of such variables defined. So if I switch as a user called Saran, I might have different set of paths. See here there is something extra called root bin. Here I have home Saran bin, and some paths may not be present. If I want, I can add them. Okay, so every user when he is executing a command, it will go and check in these locations whether the binary is present. If it is not present, it is almost like if I do xyz, it says command not found, because this command is not present in those locations. So that is one possibility. Second possibility is, in fact, there is no such command called xyz. Okay. Coming back. So cron will check in these folders. So this is the path variable for cron. So this is the shell for cron, mail to root. So cron, after executing, it will send a mail to root. If you are a root user, you can type mail, and mail will give you. So in the system, there is a command called mail, using which you can send mails to others. Okay, and at the same time there is a small inbox created. You just have to type mail, it will open the inbox, and then it says it has sent one mail to one of the user I have created in the system. You need to type this number 1, then it will show the corresponding message. So this user is not in sudo list. That means yesterday, as this user, while explaining the sudo concept, what I did is I tried to use sudo command even if this user doesn't have sudo access. Okay, so then it will throw a message that this will be reported. So reported to whom? It has reported that incident to the root user. Okay, so everything, so from a security perspective, so everything that you do such kind of things, they will be reported to the root user. So that has come to root user's mail. Similarly, every user have account. Maybe remind me about the mail command. So there is one command called mail, and there is another command called mut. I'll explain these two commands later. So these two commands are used. One is for generic email sending purpose, mail command. You cannot send attachments using mail command, but using mut you can send attachments also. Maybe you can make a note and Google, it's up to you, or I can explain later. So coming back, so these are the variables for cron. So then so how does cron runs jobs at a specific time? How does it remember when to execute, how often to execute? So for that we have a set of parameters here that we configure. So if you observe here, okay, again remember that special what do you call it, the star which we were using, rm-rf space star. What does it do? It will delete the content, all the contents of the current directory. So star matches everything. You remember that, right? So even here star does a similar job. It matches all the possible options or arguments. So what arguments means? So there are totally 5 places here as a part of cron job. Okay, 5 places followed by user and the command to be executed. So the first place, it denotes the minutes 0 to 59. So if you want to be specific, if you say 5, so it is like on 5th minute you have to run this job. Okay, so day and all those are followed by it. So when you say 5, so the job will run on 5th minute. Okay, so if you say something like uh, star means it is matching every minute, so the job will run every minute of the day. Clear? So that is how you can be specific for a minute, and you can also run every minute. The second value is hour, so 0 to 23. That means if you want to be specific, I want to run my job at 2:30 p.m. So then you mention 2 here and 30 here. Clear? 2:30 p.m. means 2 comes here, 30 comes here. Whereas if you did something like 30 here and star here, so every hour 1:30, 2:30, 3:30, 4:30, every hour. So because star is matching every hour. Similarly, day of the month. What is the day? And then which month it is, and then what is the day of the week. So these are 5 parameters. Now you pick any random requirement. Okay, I want to run a job. Usually, jobs like log deletion of the logs and some jobs which involve processing a lot of data, they are executed at the end of the day. So usually during the business hours. So people don't run such kind of jobs that would impact the business. If something goes wrong, it might impact the business. So it is like off working hours. What they do, they run the jobs on the database or something like that. Okay. So let us take the considering that example. So I want to run a job every day at night 11:30 p.m. Okay. So what are the options that you have? So here it is 30, 11, every day of the week, every day of the month. So 30, 11, star. So this is the time that I've scheduled. So the clock is set. Next is the username. So on as what user you want to configure it. Okay. So this is optional because so if I switch to a user called Saran and I configure a cron job, okay, that means my own cron configuration file, then it runs on my name only. But if as a root user you are scheduling a cron job that has to run as some other user, then you might need such argument username and then command to be executed. So provide the path of the script. So this is the script that must be executed by cron. That's it. So the cron will, so the moment you have provided these arguments, so cron anyhow is running in the background. Cron will periodically check whether there is a cron job scheduled in the system. If it is scheduled, then it will check the corresponding time slot and it will start executing it. So let us configure a cron job rather than waiting by scheduling it at some time randomly. What I'll do is I'll simply put a star here, all stars. So the job has to run every minute. The moment the job has been identified, it has to start running every minute. Okay, so that is what the example we will take. We will try to be some other user. So how do you open? So the cron tab is a global file. Usually the way we configure the jobs is by using a command called crontab-e. So the file which I showed you before, it is etc crontab. Okay. So like we have etc sudoers file, but how do we open it? We use vi sudo. Similarly, we say crontab-e. The difference between vi sudo and cron tab -e is, so with vi sudo it is the same file that is opened in a vi editor irrespective of the user. So only root user generally has permission, others don't have permission to open the vi sudo file. That means they cannot modify it. So by the end of the day it is the same file that gets opened. Whereas in this case, as a user, if you do cron tab space -e, it will create a user specific config file. So as a sudden, if I create this configuration, so this is a different file, and if I switch as a different user and I do cron tab -e, it is a different file. So before scheduling a cron job, we need to make our script ready. Okay, so let me see if there is script available. Okay, I'll try to create something small, bin bash. Okay, so let me make use of this. Okay, so I felt this is the time to show the mail command also. So what I did is I used the mail command and I sent a mail to the root user. Okay, and I logged out and I have checked that the root user has received the email. Quit. Okay, now what we'll do is we'll switch as the user. So first of all, we need to be clear on what we want to put as a part of the script. So what I'm planning to do is I'm going to put this line as a part of the script. So what the script should do every time it executes, right, is going to send out a mail to the root user every minute. So that is what we will cross check by switching as the root user. Clear? Now regarding this line, the syntax of mail command is very simple. Mail -s means subject and the user to whom you are going to send the mail, and then here this particular line which is there. So to this mail there must be some content, right? So what does echo command do? Whatever you give as input, that gives that will give it back to you. So here I am using echo. So it is like sending a blank mail, okay, a test mail without any content. So I used the command called echo, not the previous one. Yeah, this one. So echo nothing means nothing goes to the content of the file. Or say for example, if you want to put some content in a file, then what you can do is say I have created this file. Okay. Oops. Okay, let it be. Okay, so I have this file called catfy. Now I'm showing you another way of, so instead of doing echo, so if I want to put the content of the file called file, enter. So fy content will be sent as the content of this particular mail. So exit root mail. So I got another mail number 3. So the content is 1 2 3 4. Clear? So we have two ways of using the mail command. So way one is if you have a file that has content that you want to copy to the content of the mail, mail -s subject recipient, whoever you wants to send. So this operator means send the content of the mail inside the of this file inside the mail. Or if you want to make it blank, come to the beginning, echo 5. So this is a blank mail. So this is how you make use of a mail command. Done. Similarly, we have mut, where we will also include the attachment part. So my script is ready. So it will send an email every 1 minute. Bin bash. And then now I'm going to give chmod let me give full permission for now. I give full permission to execute it. Okay. Now come to cron tab -e. So it is a temporary cron tab file. Insert start 1 2 3 4 5. Okay. And where is the script? Home Saran script.sh. That's it. I have written. So cron tab -l, it will list the cron job. Say I'm going to exit as a root. Now I'm a root user, okay? And if I run cron tab -l, it says there is no cron tab for root. Now I'm going to switch as Ramesh. Cron tab -l. There is no cron job for Ramesh. Okay? So if here as Ramesh, if I say cron tab -l, sorry, E, okay, it opened a separate file. And let us try giving this. In fact, he doesn't have access to this, but I'm just, for the sake of creating it, I have created to show you that they are different. So this file belongs to Ramesh, this cron job. There is no cron job for root. Whereas if root wants, he can check it. -l-u Saran. See, it says this user has this cron job. Root can check the cron jobs of other users also. Okay, now clear, right? So every user has their own cron job file. We have verified it. We tried creating two users, two different cron jobs, and for the one specific user we created a small script. Always very, very important. Before writing a script, try to execute the corresponding commands on the command prompt. That makes the process easier. Okay, even when you go for writing bigger scripts, make it into pieces, run it on the command prompt, working, put it in the script. That's how you create the shell script. After creating shell script, you use the shell script, then you implement the cron job. Okay, that is the order you have to follow. Now what is our cron job going to do now? It has to keep sending emails to the root user. So I'm a root user, I want to cross check. Do you see any increase in the number of mails compared to the previous mails? First time I opened, there was one mail from this user. Second time I tested once. Third time I added some content, and then there are 3 more extra mails. Let's exit And what we'll do now is, you remember tail command, right? So what does tail do? Tail var log messages, it will print last 5 lines of a file. Now I want to continuously monitor the log. So I don't want to execute tail command every 5 minutes, but I want the logs to be continuously printed on the screen so that I can keep observing. For that, we can use -f command. So as the logs keep getting updated, see, you didn't get the prompt back. As the logs keep getting updated, it will wait in order to take the input and print it on the screen. Okay. Now we use the same concept to check cron. In fact, two ways. Either you check the mail folder or you check the log folder, which will give you that information. Just press enter and wait for another input. So here you see, even the script, this is also trying to execute. We have also added a cron job under the name of Ramesh, and then one under Saran. So under Ramesh, we gave the path of the script which is under Saran's folder. So this user don't have access to that. So the cron tries to execute it, but it will not get implemented successfully. Keeping that apart, there you go. So we have two more lines. So you can simply press enter, you will not get the command prompt back. So tail-f is one of the important command. Whenever you observe, look into the logs, if you want to keep checking the real-time data as it gets generated, we use tail-f. It's a very important question for interviews also. Any questions on cron job? Is it clear how to configure cron? I'm just waiting for one more occurrence, then I'm going to stop both the scripts. Okay, we got it. So cron is successfully running. Control C, exit, and I'm going to stop both. So deleted it by opening it, save, close, exit, and then you become cron tab. Deleted it, save, close, exit. So I have switched in as both the users, and I deleted the cron. But it is also possible, I mean, to delete the cron jobs as a root user. I don't remember the argument. See if you can figure it out as well when you test these things. Okay, that means you need, say if you have configured 3 jobs as 3 different users, you need not have to switch as all the individual user, but you should be able to delete them as a root user. Remove -r. -r is to remove the cron tab. So you do not have to open the file and remove it, but delete the entry. You can do -r. See if you can use this way, like you do cron tab -u Saran. Now we have to list it. -u Saran -l will list it. If I do -r, it will remove it. Let us complete this. Okay. Listed, removed, no cron tab. So you can, so if there is something that you are not aware of, I showed this example because I want you to follow it. Go to the man page, figure out the corresponding argument, search for related word, you will get the corresponding argument. Try to use it. Okay, so going forward, once you are familiar, by the time you complete the course, there will be still a lot of information that you can learn, but usually you learn when the scenario comes, when the situation comes, when you have been given a task to do, you might have that. So then try to follow this process and get the things done. Okay. Okay. I don't have any questions. I'm proceeding further. Well, here it is, systemctl status, systemctl enable. There is no chk config command in CentOS 7 or Red Hat 7. You have to say systemctl. It is the same everywhere for restarting the system, for starting services, for enabling the services at the boot time. Everywhere use the same systemctl enable, systemctl start. Okay. And systemctl set hyphen default, systemctl get hyphen default. It's the same systemctl. Okay. And yeah, there is one last thing about the cron job, which is this file called etc cron.deny. Okay. So if you want to deny a user from making use of cron service, you can add that username inside the etc cron.deny file. Vi etc cron.deny. Saran, Ramesh. So both these users are not allowed to use cron now. Okay. I want you to try. So what you do is add the user inside this file and then switch to the other user and try to schedule a cron job. The system should not allow you to schedule the cron job now. So with this we are done with the topic. Okay, just one last thing. So inside var spool cron, so when you schedule jobs, cron jobs, right? So say as the user Saran, if you schedule a cron job, here you would find a file called Saran that will contain the cron job. So it has not deleted. So there are no cron jobs. That's why this folder is empty. Var spool cron. Maybe you can remember that as well. So one time as a root user, you don't know how many users have scheduled cron jobs. How will you know that information? So come to var spool cron. So you can get to see all the users who have configured the cron jobs in the system. Okay, for sure cron topic is over now. Okay, move to anacron. So cron is the main topic. Anacron is another scheduler that is available, whereas anacron is a good fit mostly for laptops and desktop users, because anacron has a different style of implementing the scripts in the system. Okay, so it follows a different type of clock. So here you can see the period is daily, weekly, monthly, and you can also specify the number of days. Now what this means is, take an example. So you scheduled a job that has to run at 2 p.m. every day. Suddenly your computer is down, your server is down for the entire day. Okay, and tomorrow morning you have started the server. So what about the job that you have scheduled to run at 2 p.m. yesterday? Since your server is down, the job didn't run. Okay, so cron cannot do anything in that case. But anacron, okay, if you schedule the same job using anacron, the moment you start the system, Okay, after you start the system, Anacron will run the job for you. Anacron has that functionality. We can also specify how long Anacron has to wait after system gets started. Like say, don't immediately execute the job, but wait for some time so that it ensures that the system is stable. Then you execute. So wait for 1 hour and execute. Wait for 2 hours and execute. Like that, you can specify the time also. So that is the period, n number of days. Okay, so that is the additional functionality we have with Anacron, but not with cron. Another difference, Anacron can be configured only by root user. Non-root user cannot schedule jobs using Anacron. But when you compare with cron, every user has access to cron jobs. Okay, so I think these are the main important differences. Well, if you want to try Anacron, etc Anacron tab is the corresponding configuration file. As I said, only root user can schedule jobs, so you can try updating the Anacron. Okay, Anacron also makes use of these folders: cron.daily, cron.weekly, cron.monthly. And then we have another scheduler of the simplest form, which is et. So using it, there are no config files, but simply a few more commands. Okay, so if you want to try et command, okay, there is no example here. Et now ls. Okay, it is not installed in my system. So it takes the job as well as time on the command prompt itself. That means at space 5 p.m. Friday, give the job name, script name. So that goes into the queue of at command. What is the time? Or at 10 p.m. execute ls. I forgot the syntax for it. atq is the command using which you can check the at job queue. At command atq, and if you want to remove the job that you have scheduled using at command, we use atrm. You can also schedule some batch jobs using at. I'll just refer to the format. I don't use the at command, but it is just for reference. There is another scheduler that is available using it. Okay, I'll check and let you know. Meanwhile, you can also try it out. So the format would be just at space sometime space the job name, or you can give any command as an example. Let me just try one more time. At 5 p.m. ls syntax. That's okay. I couldn't figure it out now. So we'll move on to the next topic. We have two more commands in Linux. One is nice command, another one is re-nice command. Okay. So every process that runs in the system, right? So when you run top command or ps command, we get the list of processes and a lot of other details. So one of those column is about the priority of uh, priority at which the process is running. That means the priority with which the process is getting CPU time. Okay, based on that only the process gets executed, right? So by default, I mean, there is a range for this priority, that is minus 20 to 90. So minus 20 being highest priority. So if you look at the process list, processes that have minus 20, so they are going to get the next CPU time, okay, possible CPU time. So 19 is like lowest priority. So default when you start a process, okay, mostly it would be running with a low priority, whereas if there is a scenario, okay, or a specific request to speed up a process, it's not like every time a process gets implemented in the next few seconds. Some processes would take a lot of time, so based depending on the priority as well. So if you have a requirement where you have to change the priority of the process, make it executed quickly, or delay the process, let the process be delayed because we cannot stop and start if there is such kind of scenario. So what we do is we change the priority, make it the lowest priority so that it runs slowly or make it fast. So that is possible using nice command. So nice command would actually, we have both nice and renice. Okay, so nice command, what it does is before starting a process itself, you can set the priority with which the process has to run. Okay, if there is a process which is already running in the system and you want to change the priority of that process, then we use renice commands. Okay, that is the difference. Just remember what these commands are, what the functionality is. So nice is before starting a command itself, if you want to set the priority, nice will work. If a process which is already running, if you want to change the priority, then use renice. Okay, with this, let me open another section. Well, the slides that I'm about to send you, I have realigned the topics. So I'm just going through the slides to check if there are any topics that I've missed. Okay, so we have covered all the topics from the first two presentations. So you should receive them today. Okay, so let's move on to the next topic, which is about creating partitions in a Linux system. So we have an overview, we have seen about Linux permissions, right? I hope you did practice those commands, read, write, execute permissions, and what else we have seen? 421, the numeric representation, and also the alphabet representation of these permissions. And another thing, so let's finish that. There is one small topic that is related to permissions. So we did this, right? We used chmod command and how to change the permissions for individual files. excuse me, how to change the permissions for all the files present in a directory and subdirectory. That means recursively by using chmod -r. We did that also, right? And I think we forgot to check on how to change the ownership of the files. So we have a lot of files here. We'll take one. Okay, so this is on the name of root user. Say I want to give this file to some other user, and before giving it to some other user, since the owner and group are root, that user may not be able to access this file. So what I want to do is, I want the other user to be able to access this file. I want to make him the owner of the file. So I copy this file, temp, go to temp, or even from the same folder, do chown. That means change the ownership. Okay, and say surrender. So either use the same group or whatever group that you want to give. Okay, and then test file. So Saran is the owner of the group. The same concept if you have a bunch of folders. Recursively change the owner and group for all the files and subdirectories in a particular folder. If you have a folder and a lot of files inside XYZ, then you can run the same command in a recursive way also. Okay, and say for example, you need not have to change the group. Okay, so recursive you understood, right? I'm just taking it out. Say you have a file for which it is sufficient if you want to, if you can change the owner, then you can simply say change owner. XYZ is not there. Okay, so owner only gets changed, and if we want, we can do change group. Okay, and you can use chown command itself. So the format is owner colon group, right? So you can say this colon group. That means colon Saran. So these are all different ways in which you can change the owner as well as the group for a particular file. Clear? Now, so we are not done yet. There is another topic. Okay. Now observe closely. So it says touch file 1, file 2. So first of all, who am I? I'm a root user. And as a root user, I created two files, file 1 and file 2. And then I created two directories, dir1, dir2. Now observe the permissions that are associated with those files. So both the files, file 1, file 2 have same set of permissions. Both the directories have same set of permissions. That means as a root user, if I create a file or a directory, by default, there are some permissions that are being given to those files. Understood? So there is a default set of permissions that will be given when I create a file. So if I create another file, so we have same permissions. So what are the permissions? For file, it is RWRR 644, and for directory it is RWX RXRX 755. Okay. Now there is a command called umask. Umask defines the default permissions that must be given to a file when it is created. Umask defines the default permissions that must be given to a directory when it is created. Okay. Now, how do we calculate using umask is, what is the, so there are 4 places in umask. I want you to skip the first place now. So consider umask as 0 to 2 only. Okay. Oops. So that command will change the umask. Okay. So for a root user, so what are the total permissions? 777 is the max minus umask 0 to 2. What do you get? 755. So this is the default permission. Okay. If it is a non-root user, again it differs from root to non-root. If it is a non-root user, instead of using 777, you have to say 666 minus umask, whatever umask is set for the non-root user. If it is 0 to 2, then the resultant permission is 644. That will be assigned to the directory for a non-root user. So let's check that first. No, it is different. Umask is different here. So it is 002. So if I create a directory, so for root you have to subtract from 777. For non-root you have to subtract from 666. So 666 minus 002, you will get 664. Okay. Okay, I think I have confused. Just 1 second, sorry. Let me open that slide. Just give me 1 second. Sorry everyone, I forgot to include this in the slides. So I'm just showing the corresponding permission information on the screen. I will include that as a part of third module while sending the presentation. Okay. So here you can see. So for a directory, the default permission is 777, and for a file it is 666. So the umask value is different for both. So you just have to subtract the umask value. So if it is root, for a directory it is 777 minus umask, whereas as a root user, if it is a file, then 666 minus umask will give you the permissions. Similarly, for non-root user, for a directory it is 777 minus umask, for a file it is 666 minus umask. Any doubts on this? Is it clear? So this is how the default permissions will be assigned to the files and directories in a Linux system. Is it clear, or should I repeat this? Okay. So in umask, uh, there are 4 numbers. I told you to skip the first number, right? So that is about special bit that is set. Other than RWX, we have 3 more kind of permission related bits which belong to that place. So we'll see that later. Okay. Now we'll quickly go through the topic on creating partitions in a Linux system. Okay. So we know that there are 2 types of partitions present: primary partition and extended partition. So extended partition is like a container inside which we create uh, logical partitions. Okay, as per the restriction we have with master boot record, we can create a maximum of 4 partitions, 4 primary partitions only. Now, can anyone of you tell me why we can create 4 partitions only? As a part of the booting process, I have explained about MBR. I said because of this reason, we can only create 4 primary partitions only. So what was the limitation? Not the names of the partitions. I told you why we can only create 4 partitions. MBR has a size of 512 bytes. Out of 512 bytes, only 64 bytes has been allocated for the partition table. Only 64 bytes. Each partition occupies a space of 16 MB. So we can create only 4. So 64 can accommodate only 4 primary partitions. Okay. So this is with MBR. So this concept is till MBR. So after MBR we have latest boot records that are available, latest uh, features that are available, using which we can also more number of partitions. That is a different topic. So with respect to MBR, this is the limitation, and this is why we can only create 4 primary partitions. So in a system, either you go with 4 primary partitions or you create less primary so that you can create extended partitions. So first of all, to check the partitions, fdisk-l is the command using which you can check how many partitions are available in a Linux system. So we know SDA1, so star is there, it is the boot partition. So that is the partition from where all bootable files are present. The system will try to boot the system. SDA2 is the actual root file system. The rest of the entire operating system is mounted on SDA2. SDA3 is the swap partition. Remember swap partition, it mainly helps RAM, it stores the swap files, the old pages which are there in RAM that are, so as the RAM gets built, it will try to move those pages from RAM to the swap area. It is a part of your disk but acts like a RAM. So these are the 3 primary partitions that we have chosen. Okay. Other than that, we have the 4th partition system. So what we'll do is we'll try to delete this partition and recreate a few partitions in the system. So that's what we'll check. Another important thing here is you connect a USB drive to your system. Okay. Take Windows as an example. So when you connect a USB drive, what happens? So it will be detected and a new window will open displaying the contents of the USB drive, right? Say for example that drive has been, so it is also considered as a drive. Just like your hard disk has a C drive and a D drive, your USB drive or USB disk also is considered as a drive. And say for example it has been assigned a letter called as G. So under my computer along with CD you have G drive. Okay, and when you double click, a folder opens that contains the contents. Now basically what has happened is your disk or the USB disk which is there, so that is linked to a point in your system. So the point name is G. Okay, so the point G which is there in your system, operating system, it is linked to the external disk. So by linking, what happens, you can open the contents of the external drive by clicking on this point. So consider it as a folder. G is a folder. So by clicking on G, you can see the contents of the external drive. Similarly, your hard disk has 2 drives, 2 partitions. One is C, another one is D. So that is what you have chosen during the installation of Windows operating system. So if you double click on C, you get to see all the Windows system files, and you have created a separate partition called D in order to store other data. So in the underlying background, what is happening? There is a partition on your hard disk that is linked to a point, a folder on your Windows file system. Okay, that is named as C. Another one D. Now I said G. The same concept is applicable for a Linux system. Here, that linking which is there, it is called as mounting. Okay, so in this output, so this is our hard disk partitions. So partition dev SDA1 is mounted or linked to a point called /boot on my file system. /dev SDA2 is a partition on the hard disk. It is mounted or linked to a folder called /. Swap partition doesn't have a mount point. /dev SDA4 it is a partition. I don't know where it is mounted. To check, we can use the command called mount and pipe and grep SDA4. It says /dev SDA4 on means mounted on or linked to a point called /mount6. So if I go to /mount6 or in graphical mode, if I double click on /mount6 folder, I should be able to see the contents of /dev SDA4. Is it clear? So what is mounting? So I'm not going to use the Windows terminology anymore. It's going to be mounting all the time. So mount point means the access point using which we are going to access a hard disk, access a partition, access a pen drive. Okay, so mount points are access points. Now if I go to mount 6 ls, so there is nothing. Okay, create some files. So where did you create the file? Under mount6 folder? Yes, but still these files are stored where? They are stored on the partition called /dev SDA4. So whatever you do under mount6, you are actually doing it under this particular partition. Okay, so if you break the link, okay, in Windows what happens? If you remove the pen drive, the G drive is not visible. But here, even if you break the link, mount6 folder is available. How do you break the link? You say you should be out of the folder first, okay, and then say umount. You give /dev SDA4. This is one way. You can also say directly mount6. Both the steps work. So the chain is broken. Now go to mount6 ls. There is nothing. But we created some files, right? Where are they? They are stored under /dev SDA4. So if you want to see the contents of /dev SDA4 again, you need to mount it. Okay? And in Linux, we can mount this partition to any folder. It's not like automatically it will be detected under only one particular location. So that feature is also there, that is different. But mostly you would see the manual mounting only. Okay? So say this time I want to mount it under temp. Mount, partition, mount point. Now see the contents of temp. So it will only display the contents of this partition. Now unmount. Now check the contents of temp. So actually temp folder has some content. The moment you mounted it to SDA4, it's like it has hidden the contents of temp and it is only displaying the contents of /dev SDA4. Okay, is the concept of mounting clear? Just please give me a confirmation. Is it clear? Have you understood what mounting means? What is an access point? So what happens when you mount a partition? What happens when you unmount a partition? So based on the same concept, we have multiple partitions in a Linux system and their corresponding mount points on the file system. So whenever we are creating a partition, if you take the manual process, so we create a raw partition. So the raw partition is not sufficient to store the data. You have to define a file system. It's like a set of rules, okay, or it is like the boundary walls on the raw disk. You need to draw them first, then only you can store the data. So you write the file system on the raw disk, and okay, now the disk is ready to store the data, but how are you going to access the disk? You need a access point, so you mount it, then you start writing to that partition. Okay, once again we create a raw partition, so taking a slice out of your hard disk, so it is not ready to store the data. You need to write a file system on the raw partition. So once the file system is written, You can store the data, but first of all, in order to access the partition, we need a mount point. So you mount it to a location in your file system. Then you start writing data to it. So 3 important steps. Okay. Now, first step, how to create partition. fdisk-l, you have seen the same command using which we have verified the partitions. Clear. So using fdisk command, you need to give your hard disk as an input /dev sda. Enter. M for help. These are the options available. Out of all these options, we will only use some options. Like, we'll start with L, list the partitions. These are like file system labels. Okay, I'll press M to go back. I'll tell you why we use that. And then P is to print the same information that you see in fdisk-l. Again M, enter. N is to add a new partition. Before adding a new partition, let us delete a partition. D. So we have partitions 1 to 4. We want to delete partition 4. So I give 4 as input, enter. Now P. So this is temporarily showing me. So it has not deleted it yet. It is just, I'm just cross checking what will happen by giving 4 as input. Okay. So if it executes, this is the output that I'm gonna see. I am fine. W is to save. Okay. So the partition is deleted. But if you read the output here, the partition table has been altered, calling ioctl function to reread partition table. So kernel maintains partition table information. Okay. So after you delete a partition, what happens in the background is a function is called using which the partition table is updated. But there is a warning message. It says rereading the partition table failed with error. Device or resource busy. The kernel still uses the old table. Sorry. It says that the device is busy. There is a possibility that the device is busy because it is still mounted. We have to unmount the partition before deleting it. Okay. So let us check if it is mounted. It is not mounted. But still there is an error. Okay. So in order to overcome this, in order to ensure that the partition table at the kernel is updated, we have to run the command called partprobe. It has suggested either you run partprobe or run kpartx or you reboot the system. Then the kernel will be updated. So it says warning, kernel failed to reread the partition table. As long as it says failed, so the kernel is not updated. So you cannot implement the steps. So I would suggest that double check whether the partition is not mounted. Otherwise you would face these problems. Okay. So still if you face these problems, the best solution is restart. It will get fixed. But in live system, make sure that you check whether the device is busy or not. Unmount the device, okay, and then delete the partition. Run partprobe. So partprobe will simply give you the command prompt back, which means that it has successfully updated the kernel partition table. So you have got the prompt back. That means you can proceed to the next step. Next step is about again using the fdisk utility, and so previously we have deleted by pressing the D option. Now we will use option N to create a new partition. Okay, so we create a new partition and then we cross check it, we save it, and once you save, again you have to run partprobe command because fdisk utility doesn't ensure that partition table gets updated. So run partprobe. If you get the prompt back successfully, then that means the table is updated. Only when the table is updated, we can proceed to the next step where we write the file system on the raw partition. So after we write the file system, we create mount point, and then we access the disk using the mount point. So these are the steps. Okay, so anyhow we are running out of time. We will quickly repeat these steps again. I want you to go through the recording of the slide as well. Okay, there is some error in the system. You see this? So we'll talk about this tomorrow. I'll take a screenshot and keep it for you. Okay, so we'll go through why this problem has come up and what is the solution now to fix it. We will debug this issue tomorrow, because only we have, after fixing it, we can start with the concept of partitions. So we can cover the concept of troubleshooting in the meanwhile before proceeding with the partitions. So this is going to be useful when you learn about the partitions. Okay, so any questions for the day? Do you have any questions, guys? Okay, if you don't have any questions, then we are good to wind up. So go through the slides. You should be getting the slides today. Practice as much as you can, and we'll catch up in tomorrow's session. So we'll start the partitioning and a lot of other interesting topics tomorrow. Okay. So have a good day. See you tomorrow. Bye.